Hello everyone. In this video, I am going to tell you some other code optimization techniques in compiler design. So in this video, I will discuss strand reduction, number one, second expression simplification, and third one is induction variable elimination. Okay, let's see one by one what is all about these code optimization techniques. So number one, we have a strand reduction. Okay, so first of all we will try to understand what is the strand reduction, then we will apply this code optimization technique. Actually, in compiler design, after intermediate code is generated, code optimization is carried out. And what is the motive behind carrying out code optimization? So that compiler can generate faster efficient target code. And strand reduction means here, suppose in intermediate code there are some costly operations, so compiler replaces those costly operations with cheaper operations if it is possible. Not every time, if it is possible, compiler replaces costlier expensive operations with cheaper operation, because we know cheaper operation takes lesser time to execute as compared to costly operation. For sake of example, multiplication takes more time as compared to addition. So if it is possible, addition multiplication can be replaced with addition operation. So this is called strength reduction. That means replacing expensive costly operation with cheaper operation. And why compiler does so? So that it takes lesser time to execute when finally target code is generated. Okay. So as we know by definition, strand reduction means in compiler optimization, expensive operations are replaced with equivalent less expensive operations. And compiler needs to take care of one more thing. When it is replacing expensive operations with cheaper operation, semantic or meaning of intermediate code shouldn't be changed. That means whatever final output it was producing earlier, it must produce after strength reduction. Okay, let's take one example. This is definition of strength reduction, and let's see example here. Example, in example number 1, compiler can replace x into 2, that means this multiplication expression, with this left shift operation. Why compiler doing so? Because left shift operation takes lesser time to execute as compared to multiplication. So here x into 2 is costlier or expensive operation, so it can be replaced with this right shift operation. So this is preferable. Okay, so after strand reduction, this code will be replaced with this code. Okay, and second number, suppose you have to calculate power of a number. So if in intermediate code there is a function to call power m comma 2, so this function call takes more time as compared to multiplication. And we know m into m is same as power of m2. So this costly operation, this can be replaced by this m into m. Okay, so this is known as strength reduction. I'm summarizing it. Strength reduction code optimization technique means compiler replaces expensive costly operations with cheaper operations. Let's see second. Second is expression simplification. Expression simplification or algebraic simplification. Okay, we can also call it algebraic simplification. And using this code optimization techniques, compiler removes some expressions that are not having any meaningful part during execution. For the sake of example, take example number 1. X equal x into 1 can be eliminated because after elimination of this statement, x would have same value. because multiplying x with 1 multiplying x with 1 and assigning it into x, it is not having any meaning. So compiler can eliminate this statement. Okay, second, you can see this one, second number, y equal y plus 0. This statement can also be eliminated because after elimination, semantic or meaning of source code or intermediate code would be same. So compiler can also eliminate them. Okay, so what is expression simplification? This is definition of expression simplification. Some expressions can be simplified by replacing them with an equivalent expression that is more efficient. Again, we need to keep one point in mind. When we are replacing with simpler expressions, so meaning of intermediate code shouldn't be changed. Okay, every time we need to keep this thing in mind. Only then it would be preferable, otherwise it is not preferable. Okay, so again I'm summarizing expression simplification. Compiler can eliminate expressions that are not having any significant meaning of target code, like statement number 1, statement number 2. Okay, let's see next code optimization technique, that is the induction variable. It is very important because it is also asked in competitive exams, induction variable. So first of all, what is the induction variable? Induction variables appears within a loop. First of all, we need to know this thing, and two variables I and j. Okay, I and j, two variables are called induction variable if changing value of one variable changes value of other variables by a fixed constant value. Okay, so again, how to identify induction variable? Okay, look at this loop. For loop, for I equal 1, I less than 11, and plus I, and within loop there is a statement j equal I plus 5. Every time, in every iteration of loop, value of j is getting increment by 5. So we will say I and j are induction variables. Okay, again, how to identify induction variable? Two variables are called induction variable if changing value of one variable also changes value of other variable by a fixed constant value. What? Fixed constant value. Okay, so such variables are known as induction variable, and compiler also eliminates such kind of variables because executing expression having induction variable takes more time. Okay, so in order to speed up finally target code, compiler eliminates induction variables. Again, I am repeating definition of induction variable, this one. And variable is a variable, an induction variable is a variable that gets incremented or decremented by a fixed constant value on every time of a loop execution. Okay, so how to eliminate induction variables? Look at here. As we know, in this source code, every time for a value of I, j is incremented by 5. Okay, if you observe this code, you would find out for every value of I, j is incremented by 5 every time loop is executed. Okay, so we can optimize this source code in this way. How? We can write down j equals 0 and loop would be same. Okay, and within the loop we can write down j equals j plus 5. Okay, so why we are writing down j equals j plus 5? Because we have observed here for each iteration of loop, value of j is incremented by 5. So we know this multiplication operation is costlier as compared to addition. Okay, as we have already discussed in Strand Reduction code optimization technique, multiplication is expensive. It means it takes more time to execute as compared to addition. So when we eliminate induction variable, we can write down code in such a way that means this multiplication can be changed into addition. Okay, again after code optimization, this code optimization, meaning of source code shouldn't be changed. Meaning of source code shouldn't be changed. Okay, if you observe clearly, you would come to know effect of this optimized code is same as of this original code. Okay, and this induction variable elimination is also one of case of strength reduction. Strength reduction. Okay, why it is case of strength reduction? Because here look at here, this multiplication has been replaced with this addition. Okay, so also induction variable elimination is a case of strength reduction. Okay, so again I am summarizing what is induction variable. Two variables are known as induction variable if changing value of one variable causes changes in another variable by a fixed constant value. Okay, if you find out such kind of variable within a loop, they are known as induction variable. And using code optimization technique, you can rewrite, I mean compiler can rewrite existing code in such a way that induction variable can be eliminated. Okay, thank you everyone. If you have any doubt, you can write down in comment section, and you can ask me. Okay, I will reply you there if you are having such some kind of query or problems. Thank you everyone.